Yes. Thank you so much for everyone that is made this tour possible. We're all excited. We have select board here, we have energy committee, and we have neighbors. So this is really nice. So with that, who should we turn it over to?
Well, why don't we do introductions first so everybody knows who everybody is.
Okay.
Starting with the select board.
Okay. Hi, I'm Jeannie Jenkins. I chair this board. Yeah, we have to do that part, don't we? Okay.
I'm Jean Connor. I'm the vice chair.
Hi, Tom Haley. Gary Corey.
Bruce Lee Clark.
Okay. Mike, why don't we start with you?
Mike Lane, Assistant Chief.
I'm Stuart Hurd.
Larry Gates, Town Bank.
RJ Jolly, DPW Director.
John Moore, Chief Operator.
Lucas Harrington, Laboratory Technician.
And Bill Karras, Chair of the Energy Committee.
I'm Leslie Jacobson, a neighbor down the road.
I'm Ron Dubriel, the neighbor down the
What we're going to do
road.
first is we're going to just give you a quick overview of our SCADA system. Mike will run it through with the computer. So you can see, basically, at most of the plant, we can see what's operating through SCADA. There's some adjustments that we make here. And
You can control quite a bit.
right. So we can control certain pumps and times and processes right through SCADA now.
This also controls our alarm set point, so if a tank goes high or low, or chlorine goes high or low, high flows, high wet wells, anything, a pump fails, we'll get any alarm through anything in the plant.
Was
through
this
here.
system part of the upgrade?
This was part of the
Yes.
upgrade.
That also will call the operators when the alarm happens, so we get notified when there is an alarm.
So
don't
you
have to
get
be
calls
here.
at home?
Yeah, on our cell phones, yes.
And this entire room is part of the upgrade. This was all
Okay.
added.
Yes.
This did
Yeah.
not exist.
Right.
Nice.
So with SCADA, it gives us also a lot of charting, so we can go back from when we turn SCADA on and see all the charting, the flows, what happened, so we can see some neat trends of different things, what things are doing and what's not working because, you know, it's not efficient, or like we realized one of our main raw sewage pumps was not efficient because it would run, but every time it would run, another one would run. So only on that pump. So it was actually just idling along, doing nothing. So that went out to be rebuilt. It's actually currently out right now. So this just gives it a lot of control and visual of the plant. And at a glimpse, walking down the hall, you can kind of look. If there's something wrong, it'll be blinking red up there. The alarm will also call a few minutes later. But like if one of those RBCs up there, the green squares, there's those 32 white huts up on the hill that we replaced. If one goes down, that turns red. Anything that's green can turn red, means it's failed, or an alarm. So it's kind of neat. Yeah.
Okay, we're just going to follow the flow of the plant, so we'll go to the screening building first.
Oh, goody.
Yeah. Was that, yeah. All right, so basically all the flushable wipes that everyone keeps flushing is a huge issue for the wastewater plants. So this was added during the upgrade to take those out of the system. So one story down, there's what we call a fine screen. All the rags collect on that, and then eventually it automatically rakes them. It comes up into a little wash unit, washes them. Comes up through here. We actually bag them because it doesn't wash as well as we'd like, so we bag them for odor control. And twice a week this is full, and we have to run this to the transfer station. So before that we'd have rags through the whole system, so this really eliminates a lot of the rag issues that we have. So it's been a really, really good part of the upgrade.
Are those pipes recyclable?
No. They were just they're a maintenance nightmare. They shouldn't ever be flushed, actually. It's just something that they marketed that you could flush them, which you can, but then they don't break down.
This pretty much takes out anything coarser than a quarter to a half of an inch. So if it's a stone, if it's anything that takes it down, the pipe.
Kids' toy.
Needles.
Oh, yeah.
Needles, kids' toys.
Yep.
Yep. It will come up through there.
Other things more valuable.
So that goes down a story, and it's in the water, the flow of the water into the conveyor, pulls it up,
Yeah.
puts it into this washer, and bags it there. So it's about 1,000 to 1,500 pounds a week of rags that we haul away.
What you hear, the noise you hear is really dripping. So what happens there is this area, so it's water, everything comes to water, so water, like the same. From there, when the pit chamber goes into a wet well, which is controlled by 4 fluid pumps and 4 power pumps. And they pump it from there up to the clarifiers. And that's for settling rate for recovering all of our stuff.
John, so what would it take to actually have no odors in this? How would you do that? Would you have to put a bubble over each one of these? I mean, is it even possible?
I would say it's not possible.
Not safe.
Once you start closing the spaces, you're creating another problem with entry into it.
We make methane gas. That dome right there is floating. That will change levels, and that's methane gas.
Well, I ask because it comes up as a question. And, you know, I mean,
It'd be impossible, because then you're dealing with other issues like sulfur, methane, and other functions. We already have enough of those. All right, so these are the main rise sewage pumps. These are what's pumping the whole flow coming into the plant right now. So we got 2 of them are running. They take the flow from that wet well that we were just outside at. They pump it up to the clarifiers. Different electrical controls here for different parts of the plant. One of our standby generators over here in the corner. So when we lose power, this is we have to have continuous power. So our generator powers this side of the plant, all the primary of the plant.
Is it off your gas? Is it off your generated gas, or is it diesel?
No, that one's diesel. Yeah, well, actually they both are. The other one that powers the other side is diesel also.
So these 4 pumps are the only pumps that pump all the flow. So without these pumps, this can't happen. It takes it from 3 stories down and pumps it up there, and the rest is gravity through the plant. So these are 50 horsepower motors. There's 4 of them. Normally it's only 1 or 2 running at a time. Every once in a while, during like Irene, the 3rd will kick on, but never 4. 4 is too much, it will overflow.
And they're on a VFD, controlled by group pump?
Yeah, they're all on VFDs. And they run on the wet well level, so they ramp up and down accordingly. So if it gets too high, the lag will kick on. When it gets to a nice level, the lag will shut off. So this is how we learn. That one's actually out of commission. There's a drive shaft piston that goes 2 stories down. every drop of wastewater comes through here goes through one of these 4 pumps. But that drive shaft is coming from the motorway up above. The wet well is just on the other side of the wall from us, so there's thousands of gallons of water on that side of the wall. That's the suction pipe there. So, that's the one that's out right now. So they took this whole section. You have to get it out onto the trolley over there and up 3 stories.
Alright, I guess everyone's here. So these are the primary clarifiers. So all the wastewater that those pumps are pumping is coming up here. So they're put in these tanks. They get it, depending on flow, you know, settling time anywhere from an hour to probably 2.5 hours. What's happening now is it settles. These flights that you see right here, they're moving really, really slow. So they take the scum on the top layer, they bring it over to those troughs. He was just manually collecting it where we collect it and then we can pump it to the digesters. And the chains disappear underground, under the water, and they pull the bottom of the sludge on the floor of the clarifiers that settle out to tanks, a little hopper below us. And this is a pump pit, so the pumps take the sludge that settled out and we pump it from here down to those 2 round buildings. Those are our primary digesters. Those are like the stomach of the plant where we start digesting all of this process.
Oh, that too, yeah.
Does that record audio as well?
Right, so this is the primary digester. Like I said, this is basically like the stomach of the plant. So we start digesting all the sludge that's pumped on the clarifiers. It comes down and it's split into the 2 tanks that we have here. It's heated. All the sludge is kept to about 95, 96 degrees. And that's where we get bugs that are called methane producers. It's a mesothermic level, so that's what the temperature they like. they produce methane. So the methane is sent and stored at the next digester called the secondary digester, and that cover you see, that big round cover, that's floating on methane. That's the gas that we use. And we use the methane in this boiler here to heat the sludge, so we're using our methane to do that. Then daily we're doing draws off the primary clarifiers. It's set at different time intervals, about 6 times a day. It's automatic, so it comes down here into this process. From here, once a day we do a transfer, so we take sludge out of these 2 tanks and we send it over to the secondary clarifier or the secondary digester. And from there, that's basically a big holding tank. And from there, we have to get rid of the sludge somehow. So that's where it goes into our dewatering and composting facility. So that way we're getting rid of our sludge, and it's getting more and more difficult to get rid of sludge at this point. So really dewatering is a great process for us in our compost. Yeah, it's not only that, but we also help manage the brush pile at the transfer station. So we actually grind all the trees and branches everyone brings in, and we use that here. So we have that double ground, and we bring that here to mix. That's what we use in our compost facility, along with the sludge. So that's kind of a great process in a couple of ways.
So there's a lot of engineering and science to this process.
Yes.
I assume that most of the people who work here are certified. What's the process for that, and how long does it take?
Okay, well, the process is, so there's 5 levels in the state of Vermont, 1 through a 5. And most operators have to be a grade 1 within 2 years. So there's a testing process you go through, normally some class work, and the tests get progressively harder from a 1 to a 5. So every operator has to be a grade 1. My position as chief operator has to be a 5. Mike is also a grade 5. Our lab tech has to be a grade 3. So those are what the state tells us we have to be. Other than that, the operators are encouraged to go higher because it's just better. The more knowledge they have, the better off we all are. So they're encouraged to get higher grades, definitely.
And they're compensated for that through the union agreement. So the higher their grade, the more pay they get. So there's an incentive to continue to move up.
What did you say happens to the compost in the end?
So the compost that we make, what we do, the finished product, first of all, we can't get rid of any compost until it's tested, so it goes through a testing process. Once it's cleared and tested, we actually, the Public Works Department, Highway Department takes it and they amend the topsoil with it. So we actually use our own compost. So on their jobs where they're doing a lot of topsoiling, it's been amended with our compost. So we actually use our own product.
My front lawn on Washington Avenue was amended by the compost. And by the way, it works really, really well.
So sort of this nice little circle that we have, but we're using our product and able to dispose of our own product. So it's really been beneficial. Back in the day, we used to market our compost through a company called AgriSource. And, we would sell it through them. We never really made any money at it. It was just a way of getting rid of it. But it was very difficult at times to get rid of it. It would back up here, and we were begging to sell it, and it made our process very difficult. Right now, it's a lot easier.
So during COVID, I don't know the details, but there was testing of sewage treatment plants. Is this when they were doing that testing?
Yeah,
no.
We applied for it, but we did not get chosen.
But this is where they were coming to test in other places?
In other places, yes.
Okay.
Yes.
Okay.
They'd probably take influent samples and test the influent for COVID.
Okay, at other treatment plants.
Yes, correct.
What is your projected population capacity for this facility here?
Well, the town being
permitted for 5.1 million gallons a day.
Okay.
Currently, we're running around
4.3 to
on average, 4.1, 4.3 on average.
Yeah.
So we still have a little bit, but in a rain event, we can go to 11 million. So, and it's like quick. So that's I&I, influent and infiltration.
Yeah.
And so that's like sump pumps in people's basement. They kick on and it goes to the sewer, that all comes here. So we're trying to treat all that. And if it's all the sump pumps in town that's doing it, or manholes, water running into manholes, or leaky joints on pipes, all kinds of things.
everybody here. Yeah. All right, so this is our belt filter press. So this is a belt filter press. So what we're doing is we're taking the sludge out of that secondary digester. We bring it over here. We mix it with a polymer, which makes it thicker. It looks kind of like cottage cheese, and it's run through the rollers. So the rollers get bigger and bigger as the sludge goes through. So it presses out the water. So this is what's coming off here is been through all the press. It goes here. It goes into basically this truck, which we take out into our compost facility to compost it.
So this is taking liquid sludge. It's like a consistency of, say, a milk cake, approximately, and it's making a dry material. It's 16 to 20% solid. You can make a snowball with it. It's tacky, but it starts the drying process. So this does most of the work getting rid of the water, and then composting brings it up to a high temperature and kills all the pathogens and breaks it down further. Walk out.
All right, so this is the compost facility. So we run 4 bays of compost. Each bay is 180 feet long. So a plug is about 12 feet long. It goes in. We do a floor mix with the compost. So we do our chips and our sludge on the floor. We mix it. We load a bay. It's put in the bay. And then this machine here called an agitator is run. So what it does, the agitator does 2 things. It moves that pile 12 feet every time, so it goes to the offload end when we're done with it, where we take it out, and also mixes it well, so it keeps it mixed. And the bays are aerated, so there's air being blown up through the bays, so these heat up. So we have to meet certain criteria to make Class A compost. So we need to meet 55 degrees Celsius for 3 days and consecutive 45 degrees Celsius for another 15 days. So we have to manually every day walk these piles, take temperatures with a probe to see where we are in temperatures. We record it for the state so we know where we are with our temperatures.
Historically, this building was built in 1983 in response to the fact that we were going to take our sludges and land apply them in a contract with Fairdale Farms. Ultimately, the people of the community that lived out there were concerned about what that would do to their wells. And so we went back to the state of Vermont, we applied for more funds and built the compost facility. So this came along after what you normally see. And now, thank God we have it, because it does allow us to do that cycle. We can maintain.
So currently all over the nation, it's hard to get rid of sludge. This seems to be the way that everybody's going to end up going. Used to go to incinerators, that's no more. Landfills, straight sludge to landfills because of the odor issues, that's pretty much no more. During the upgrade, when we had to get rid of all of our sludge, we had no other option. We couldn't take it anywhere. Nobody would take it. So that's when we fired this back up. And it was vacant down for 6 or 7 years prior to us firing it back up in 19. And it took a week or 2 to get everything back up and running, or actually maybe in 3 weeks. But
we did it in about 10 days.
Yeah, and got it up and going, and it's been a saving grace ever since. We've got a great system here.
And we shut it down so many years ago because we were using hardwood chips, which now are very good.
Sawdust,
basically, yes. Which are now you can't get it. But it was a very, very dry environment. So we were having problems with dust and OSHA regulations regarding dust in the workplace. So we shut it down because we couldn't deal with it without bringing in some sort of a watering system or a spray system.
And now with these hard wood chips, which is everything, pine, maple, birch, you name it, it's bigger chunks of wood, and it works great. The dust isn't an issue like it has been in the past.
Where do you get that from?
What's that?
Transfer station.
Our
We
rough
grind up the material up there, When we truck into here, you'll see the bay.
Yep.
It's full.
They had a fire here in 2002. It burned. That actually caught on fire. There was a hydraulic hose that leaked, and it blew onto an electric motor, caught it on fire. So now it's got non-flammable hydraulic fluid in it, and that thing does a lot of work. When it goes all the way to the end of the bay, drops its auger down, and then comes this way, moves this whole pile 12 feet turning. Yep.
Yeah, you see that. Fortunately for us, all that equipment, the supplier of it's from Greenwich, New York.
Greenwich, New York.
So, to get this up and running wasn't like we were dealing with somebody in California.
I literally called them in the morning and they came over that afternoon and started working.
If they had something new to try out, they try it out on our equipment. It normally doesn't cost them. So we're fortunate for that.
This is finished product compost. So this is sludge, wood chips, and it's been run through the process. So it's been heated to
55 degrees
Celsius
for 3 days and consecutive 45 and nothing below 40.
So
Yep.
once this bay is full, we send out a sample for heavy metals, salmonella, E. coli, and make sure that it passes. Then we can do whatever with it. Amend
How
our
much does
topsoil.
the test cost?
It's cheaper than we originally thought. We were thinking it was like 2,000, but it's like $1,300 a test. Still expensive.
Do farmers want it?
We did. There's a place in Shasbury that grows roses.
Yeah, they grow a lot of different flowers. He took some to experiment with and try, but I haven't heard back from him since he took it.
He's supposed to
But
let
not
us know
crops.
once he knows
Yeah.
how it works.
Not crops.
Okay, so basically you saw where the sludge goes when it leaves the primary clarifiers. So now the water has to go somewhere. So the water actually is coming down here from the secondary or from the primary clarifiers, and it's split here, and it's split down all these little streams. You can call it RBC, filtration dielectric contact. So these basically grow what's called a biomass on them. Some different bugs with them will be, basically so you open one up, show you the what we're doing.
So this is full of water. So the bugs are eating out of the water.
Were these all rebuilt originally?
Yes, and part of as the upgrade, we replaced all these.
Every
yeah,
single one.
we actually did the work for that in-house ourselves all the time. So we're doing the last pumps. These are our chemical pumps, so we're going to run the pipe with chemical pumps so we can start chlorinating again. These pumps we have one that's this is a sodium bisulfite. That's our dechlor agent, so that's a dechlor chemical. This pump pumps that to the bar chamber. You'll see these two pumps here we have two chlorine contact chambers in the east and the west. So one pump pumps from one side, one pump pumps the other. And the last pump, actually, when we're using the sand filter, sends chlorination to the sand filter. So here, just for our chemicals. Next door, we have, when we're running, we have analyzers that sample the water, and we can set those to keep our level of chlorine where we want in the tanks. We run it higher in the summer, obviously, because we have to worry about, our E. coli and so forth. So we run a little more chlorine. We can run 50 to 60 gallons of hypo a day, and typically run about half as much bisulfite. So the chlorine gets used up as it goes through the chambers, and then we'll run probably about 25, 26 gallons a day of sodium bisulfite to dechlor it. We have to meet certain levels for the state, which is we can't be
For chlorine.
chlorine
0.1 can't be
0.1.
over
So
0.1.
if we're at 0.1, that's a violation. So our chlorine level has to be below 0.1 when it's going to the river. So we take daily sample measurement a couple times a day normally on the outfall. So we'll know where we are with that. So
What's the
the tracks?
That, back in the day, we used to actually chlorinate with 1-ton cylinders of chlorine gas. So 25 years ago when I started, that we just about were ending that. We ran it for a little while. We switched to the liquid. So that was to move 1-ton cylinders. That's an obsolete system. We don't use it anymore. The chlorine gas is extremely dangerous.
Yeah, that's a good one to get rid of.
Now, even this stuff here, if you get a little bit on your clothes, it will eat right through your clothes, and burn a hole right through. You get on your fingers, they start to tingle, they burn. You want to rinse it off quick. Eye washes are around. But this is much safer than the chlorine gas he's referring to. People died from chlorine gas, and it will evacuate an entire town. It follows stays low and follows the river.
Yep. Yeah, it doesn't